Willow is downloading a 2-hour movie. The function y equals 1.5 minus 0.0625x represents the number of gigabytes left to download after x minutes. How long will it take her to download the entire movie? Identify the domain and range and describe their significance. So what we need to do when it says how long is it going to take to download the entire movie is we need to figure out what the zero of the function or what the x-intercept is. We're going to start with a certain amount of the movie that has to be downloaded, and every minute that amount is going to go down, 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 and we want to know when is the amount left to download going to be at 0. That's the zero of the function, the amount we still have left to download. Okay, so how are we going to figure that out? One of the ways that we can do it is through a graph. We could graph and find out where the zero of the function is. But we also know that the zero of a function is the x-intercept. And we know that the x-intercept happens when y equals 0. So there are two different ways that you could solve this one. I'm going to show how to solve it by graphing because that's the way we've learned so far. But off to the side, I'm going to say that if you are already familiar with how to solve equations, which is something that I haven't discussed a lot with you this year, but you may be familiar with it from previous math classes, you could take our y equals 1.5 minus 0.0625x. We could take this equation and substitute 0 in place of the y and solve it for x. And that is one of the ways that you can get the answer without graphing. That's perfectly acceptable too. Okay, but let's solve by graphing because that's what we've been doing. And we graph by making an XY table. And we're going to pick just a few values of x that we'd like to use. I really like to use the value 0, as you know, just because 0 is really easy to plug in. So let's do 1.5 minus 0.0625, and then we're going to multiply that by 0. And it turns out 1.5 minus 0 is going to give us, not 0, duh, it's going to give us 1.5. So one of our first coordinates is going to be 0, 1.5. Great. Okay, so now we have to come up with some other points that we're going to use to graph this, and keep in mind that whatever points we pick are going to get multiplied by 0.0625, which is an unpleasant number to multiply by. So we want to make sure that we're picking some things that are smart for us to multiply by. And one thing that's really easy to multiply decimals by is 10. So let's try that next. So this will be 1.5 minus 0.0625 times 10. And so the reason that this is easy to do, and I'm going to show my work just right underneath it here, is that multiplying by 10 just moves the decimal over one spot. So our 0.0625, we just slide the decimal one place over, and instead of 0.0625, it's just going to be 0.625. So we're going to do 1.5 minus 0.625, which I solved before I started recording, and got 0.875. So this coordinate is not my favorite in the world. 10 and 0.875. I do not love this coordinate, but it's okay. 0.875, we can work with it. And then the last point I chose to pick was 20, which is still a multiple of 10. So what I can do is I can take what I got for 10 on the last one, and I'm still going to move the decimal over that one spot, but instead of being 0.625, it's going to be 0.625 doubled. That's what I can do with 20. So it's not quite as elegant as multiplying by 10, but it's close. And the way that I'm doing this is just if you did not have access to a calculator, this is how you would do it. If you had a calculator, then you would certainly not do it this way. You would just use the calculator as opposed to trying to pick these easy numbers. So I worked this one out beforehand and got 0.25, which is almost the end. Almost the end. 20, 0.25. That is really close to 20 and 0, which was 0 would be the 0 of our function, so that would be nice. So this seems like enough for us to graph. So I'm going to go ahead and sketch my graph. And my graph is not going to quite show me the 0 because I got to 0.25 instead of 0. But it'll give me a decent estimate. So along the bottom, the thing that we're measuring on the x-axis is minutes. And the thing that we're measuring on the y-axis is going to be the number of gigabytes left. Remember, she starts off at 1.5 gigabytes. That's how long her 2-hour movie was, 1.5, which is why our line starts at 0, 1.5. So let's go ahead and do 1.5 as our top here, and then we'll just estimate this would be like 1.0, and this would be about 0.5. And then our minutes along the bottom, we went all the way up to 20, but we're actually just a little bit beyond 20 here. So 20 is the last one we have a point for. So that's about where 10 is going to be, and we'll just go ahead and put like 15 and 5 in there. Okay, so let's go ahead and put the points on that we have. We've got 0, 1.5. And then we've got 10 and 0.875, which I'm going to estimate is about right here. And then 20 and 0.25, so it's just going to be barely above the 20. At 20, you know what, that's 0.25 would be closer to the middle here. In between 0 and 0.5, wouldn't it? 20 and 0.25. Okay, so let's go ahead and connect our dots. Seems like a good idea to get our line here. And of course, our 0 is not going to go with that. Oh, man, we did pretty good, didn't we? That is pretty close for an estimate, pretty close. I'm going to extend my x-axis a little bit because it's not quite long enough to see the, there we go. Let's extend this just a little bit, trying to get where my line will actually touch the x-axis. So it's going to be about right there. Okay, so this is the point that I'm interested in right there. That is the 0 of the function. Okay, that's the spot where the line, oops, suppose I need to move this. That is the spot I indicated right there where the line crosses the x-axis. That's the 0 of the function. So I know it's going to be more than 20. How much more than 20? How am I supposed to figure out where that is? Well, a couple of strategies we can do here. The strategy I like the most is solving it algebraically. It's more than 20, looks like it's going to be less than 25 or maybe right at 25. How can I figure out exactly where it is? We're going to do what I said you could do right at the beginning. Now we're at that point. Where we're going to replace the y with 0. So instead of y equals, we're going to do 0 equals. And we're going to see if we can figure out what the solution to this equation is. There are two different things we could do here. We could either add the 0.0625x on both sides using the addition property of equality, or we could subtract the 1.5 on both sides using the subtraction property of equality. Either one is fine. I'm going to use the addition property of equality for two reasons. The first reason is that using the addition property of equality will save me from dealing with negatives, which is always nice. The other reason using the addition property of equality is nice is that I end up with my x on the left side, which is generally where we like it. Okay, so we've got 0.0625x equals 1.5. Now we're going to use the division property of equality, and we'll just divide both sides by 0.0625. Okay, this is the division property of equality. And you aren't going to believe this, but it comes out to be exactly 24. So what does that mean? It means it takes I forgot her name. It takes our person, Willow. It takes Willow 24 minutes. It will take 24 minutes to download the movie. There we go. So there were a couple of ways we could have gone about solving this problem. We could have solved this equation right from the beginning and gone straight to 24 minutes. If you're really good at solving equations, you can go straight to the answer right from the beginning. I went ahead and made a graph here just so we've got a good estimate of approximately where our answer should be. And also, I just like making graphs. It's good to have a visual representation to go along with our picture. So a graph wasn't required, but it was a good idea. Now, the last thing is to identify the domain and range and describe their significance. Okay, so when I'm looking at this problem here, the domain, remember, is the set of all of the x values. So we start off at 0 minutes and we end at 24 minutes. So that means the domain is all of the values from 0 to 24. And we're going to write this using what is called set notation. And I'm going to write it first, and then I'm going to tell you how to read it. It looks like this. These little curly brackets there. And we do x with the line, and then 0 to 24 with the x in the middle. And the way that you read this is x such that x is between 0 and 24. And if you really want to impress people at your next math party, you say x is between 0 and 24 inclusive, because we are including 0 and 24. That's what the equal to lines mean. Between 0 and 24 inclusive. The range then, range is our set of y values, which is how many gigabytes we went through. Well, it started at 1.5 and we downloaded until there were 0 left to download. So our range is going to be from 0 to 1.5. So it's y such that y is between 0 and 1.5 inclusive. What's the significance of this? The domain is the number of minutes for which we are downloading this. We're downloading from 0 minutes to 24 minutes. And the range is the number of gigabytes we have left to download. We start off with 1.5 gigabytes and we download until we have 0 gigabytes still left to download.